All right, let's do this. Today, we're going to tackle the biggest story there is. The story of, well, everything. We're about to go on a 13.8 billion year journey, starting from the very first moment of time all the way to right here, right now. So, let's jump in at the very beginning. So let's start at the start. I want you to just think for a second. What's the first image that pops into your head when I say the words, the Big Bang?
Yeah, if you're like most of us, you're probably picturing a massive, fiery explosion in the middle of a big, black, empty space. A huge cosmic firework going off, right? Hollywood has definitely helped with that image. But here's our first major plot twist of the day. That image, as cool as it is completely wrong. The Big Bang wasn't an explosion in space.
It was the expansion of space itself. Okay, think of it like this. Picture you have a totally uninflated balloon, and you draw a bunch of little dots on it. As you blow up the balloon, the surface itself stretches, and all those dots move away from each other. See, the dots aren't running across the balloon's fabric is carrying them apart. That is our universe. And understanding this is absolutely crucial because it means the universe didn't explode into an existing void. Space itself began in that moment, stretching out from a single point, carrying everything along with it.
So if it wasn't a giant bang, how can we be so sure any of this even happened? Well, science is a lot like a cosmic detective story. We can't go back in time to witness it, but we can look for clues left behind at the scene of the crime. And when it comes to the Big Bang, the clues are, well, they're overwhelming.
The whole case is built on several key clues, but we're going to focus on two of the most important ones. The fact that the universe is getting bigger every second, and this faint leftover glow from the dawn of time, what we like to call the universe's baby photo.
First up, the expanding universe. Back in the 1920s, an astronomer named Edwin Hubble noticed something really strange. The light from distant galaxies was all stretched out, or redshifted. It's kind of like the Doppler effect you hear when an ambulance siren changes pitch as it speeds past you. This meant that almost every single galaxy was moving away from us. And here's the kicker. The farther away they were, the faster they were speeding off. This was the first real proof, the smoking gun, that our universe wasn't static, it was growing.
Now for the knockout punch. In 1965, two scientists, Penzias and Wilson, were trying to use this giant radio antenna, and they were getting really annoyed by this persistent, faint hiss that was coming from every direction. They thought it was faulty equipment, or maybe interference from New York City, or even, and I promise I'm not making this up, pigeon poop inside the antenna. So after they cleaned it all out, the hiss was still there. They had no idea what it was.
That hiss was the cosmic microwave background, the oldest light in the universe. What they had accidentally stumbled upon was the universe's baby photo, the afterglow of creation itself. A snapshot taken when the cosmos was just 380,000 years old. Its discovery was truly one of the most important in all of science. So why was it such a huge deal? Because it settled a massive scientific debate. The main rival theory back then, the steady-state model, said the universe was eternal. It had no beginning. And that model predicted no afterglow. But the Big Bang theory? It predicted this afterglow perfectly. The discovery of the CMB was the final clue that pointed directly to a hot, dense beginning for our universe.
So, case closed, right? We've got it all figured out. Well, not exactly. As with any great story, the more you learn, the more you realize you don't know. And our understanding of the universe has some absolutely massive gaps.
So what is the universe actually made of? The answer is, frankly, it's shocking. Everything we've ever seen, ever touched, or ever measured, every star, every planet, every person, is part of that tiny little slice of normal matter. The rest of it? It's a complete mystery.
Just let that sink in for a moment. We only understand the stuff that makes up about 5% of the entire cosmos. 95% of reality is made of dark matter, which kind of holds galaxies together, and dark energy, which is pushing the universe apart at an accelerating rate. We know they're there, but we have almost no idea what they actually are. Okay, but despite those massive mysteries, we know the timeline of that 5% incredibly well. So let's do a quick fast forward through 13.8 billion years of cosmic history. You might want to strap in. At 1 second old, it's a seething 10 billion degree soup of particles. By 3 minutes, the universe cooks the very first atoms, hydrogen and helium. Jump to 380,000 years, the cosmic fog clears, and light finally breaks free, creating that baby photo we talked about. At 200 million years, the first stars ignite, bringing an end to the cosmic dark ages. Then we fast forward 9 billion years. Our solar system is born from the dust of those dead stars. And today, 13.8 billion years in, here we are, looking up and wondering about it all.
So we've seen the beginning and we've flown through the middle. But every story needs an ending. So what is the ultimate fate of our universe? Well, on a local scale, our sun's story is already written. In about 5 billion years, it's going to swell up into a red giant, and it will likely swallow the inner planets, including Earth. After that, it'll puff off its outer layers and shrink down into a tiny, fading ember called a white dwarf, leaving what's left of our solar system cold and dark. And for the universe as a whole, there are 3 main ideas. The most likely, given what we see with dark energy, is the Big Freeze. The expansion just keeps going forever, until all the stars die, all energy dissipates, and the universe becomes a vast, cold, empty void. A little more dramatic is the Big Rip, where dark energy gets so strong it tears everything apart. Galaxies, stars, and even atoms themselves. And finally, there's the Big Crunch, where gravity could win, reverse expansion, and cause everything to collapse back into a single point. Maybe to start all over again in a big bounce.
A cold, empty void. That sounds a little grim, doesn't it? So why should we care about this story that started billions of years before us and will end trillions of years after we're gone? Well, because, incredibly, we are not separate from it. We are a part of it. This is one of the most beautiful ideas in all of science. The carbon in your cells, the iron in your blood, the calcium in your bones, every heavy element that makes up your body was forged in the heart of a massive star that lived and died long before our sun was ever even born. We are, quite literally, the children of the stars. We're stardust. Think about that for a moment. For nearly 13.8 billion years, the universe unfolded, completely unobserved. Stars were born, galaxies collided, but there was nothing there to know it was happening. Then, on this tiny little planet, a species evolved that could build telescopes, do math, and piece this entire story together. In a very real sense, we are the cosmos becoming aware of itself. So when you look at this whole grand, sweeping narrative, from a singularity to sentient life, from the first light to the final darkness, what is the single most incredible part of it all? Perhaps it's this, that for a brief, fleeting moment on a small blue dot, the universe has a voice. It has eyes. It has a mind. We are not just living in the universe, we are the universe, experiencing itself. And being able to understand this story might just be the most amazing thing that has happened in all 13.8 billion years.